Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 8 minus 121 equals 0. So what we're first going to do is we're going to add 121 on both sides to isolate x. We want to isolate x, so we're going to get rid of the negative 121 on this side. So these two cancel out because 121 minus 121 is 0, so we're left with x to the power of 8 equals 0 plus 121 is simply 121. Now what we're going to do is recall a property of exponents. If we have a to the power of b to the power of c, this is equal to a to the power of b times c. So what we're going to do is we're going to change our x to the power of 8 here so that it is in this form, a to the power of b to the power of c. So we're actually going to change this to x to the power of 4 to the power of 2. Because 4 times 2 is 8, and that's x to the power of 8. And this is equal to 121. Now what we're going to do is we're going to take the square root of both sides. So now the square root of this, well, these two just simply cancel because these two are opposites. So on this side, our left side, we have x to the power of 4. And on our right side, we have positive and negative 11. Remember, it's positive and negative, not just positive. So now we have x to the power of 4 equals positive and negative 11. Now we're going to take the fourth root on both sides. So by doing that, these two would cancel out. So we are left with x equals the fourth root of positive negative 11. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 512 to the power of x equals 8. So whenever we're solving exponential equations such as these, where the base is greater than the actual solution and we're powering the base to x, well, we know that x is going to be a fraction, right? X obviously has to be less than 1 because even 512 to the power of 1, that is still much greater than 8. So in situations like these, we want to convert these two bases so that they are the same. Well, 512, this is actually the same as 8 to the power of 3. 512 is equal to 8 to the power of 3. So what I'm going to do is I'm going to replace 8 to the power of 3 with 512. So we have 8 to the power of 3 to the power of x, because we have to still put this to the power of x, equals 8. Now, if we have something in the form like this, where we have a to the power of m to the power of n, and this is an important property for exponents, this is actually equal to a to the power of m times n. So a to the power of 3 to the power of x, this is equal to 8 to the power of 3 times x, which is simply equal to a to the power of 3x, because 3 times x is 3x. So now we have 8 to the power of 3x equals 8. And now if you notice, our two bases here, these two are the same. These two are equal to each other. Meaning, because our two bases are the same, our two exponents have to be the same as well. And 8, the exponent for 8 is actually just 1. Because 8 to the power of 1 is equal to 8. So because our two bases are the same, our exponents have to be the same as well, meaning 3x is equal to 1. And now we have a simple equation. All we have to do is divide by 3 on both sides. And this would cancel out. So now we'd get x equals 1 over 3. And this is our answer. Now, if we plug it in to our equation here, so if we have 512 to the power of 1 over 3 equals 8. Well, 512 to the power of 1 over 3, this is the same thing as the cube root of 512 equals 8. And the cube root of 512, so what to the power of 3 equals 512? 8. 8 to the power of 3 equals 512, so this is equal to 8, and 8 equals 8. So this is right, meaning our solution is right.